Hi, I'm Rob Horrocks and welcome to my SQL Server Kubernetes project. This recording is going to walk through this project and everything available within it. It was set up to allow you to develop, test and proof of concept working with SQL Server in a Kubernetes environment. The environment of choice at the moment is Azure Kubernetes Service, although if you strip out a lot of the code here, you can deploy it to any Kubernetes service of your choosing. So if we initially look at the README page, we can see that the solutions available are to deploy SQL 2019 and/or 2022 to an Azure Kubernetes service. You can deploy them as standalone, or you can deploy them in an high availability group. The options available are 2019 with standard availability groups, or 2022 with the new contained availability groups. So if we start with the lab setup, that will walk you through how to deploy the lab environment. As part of that, you can choose whether you want to automatically deploy the SQL Server instances and the monitoring solution, or whether you want to manually deploy yourself. If you do wish to manually deploy, there is then a set of instructions that will allow you to deploy the services that you require. Finally, there is an how to configure logins and users on SQL Server availability groups that show the potential problems that you have with logins and users in availability groups and how you can overcome them in standard and also in the contained availability group solution. So now we're going to go to lab setup, where I will show you how to deploy your environment. So initially, when we look on this page, we start with a prerequisite. The only prerequisite here is that you need an Azure account with an active subscription that has ownership permissions on it. The next section is the deployment, where we have a deploy to Azure button that we can right click and open in a new tab, which will take us to the Azure portal with a form that we fill in to decide on how we're going to deploy our lab environment. The following options are all available, and we're going to walk through each of these as we go through the form. If you wish to set up and configure availability solutions within this project, then you will need to have a license available that you add into the form itself. If you don't have a license key for DX Enterprise, then you can go to the DH2I website and download a developer license for use with this project. In terms of deployment time, it takes around 30 to 40 minutes initially to deploy the resources. Then, based on whether you're going to do a manual deployment of SQL or an automatic deployment of everything, it could take between 5 minutes and 30 minutes to go through the logon script of your SQL jump box. In terms of the resources, we start off with a virtual network, which has 3 subnets, one for your Bastion host, one for your virtual machines, and one for the Kubernetes service. We also deploy a Bastion host, 3 virtual machines. One is your domain controller, one is a Linux box, which helps with setting up Active Directory on your Kubernetes pods, and the third one is the jump box itself. Also, there will be network security groups, network interface cards, public IP addresses for all of your resources. And then finally, there will be a Kubernetes cluster, which is just a virtual machine scale set that can scale between 1 and 4 virtual machines. It will initially start with 1, which will allow you then to add more as you go through a manual installation. If you do the full installation, it will spin up 4 virtual machines as part of this scale set. Finally, we come to the actual deployment steps. Here, it tells you how to go through the form and to complete it. So we're going to go into the form now and complete one of these ourselves. First of all, if we look at the number of resources, it says 17. Eventually, there will be 18 resources that are deployed, the 18th being the Linux virtual machine, which is deployed as part of the logon script for the jump box. The first thing you will need is a subscription that you have ownership permissions to. You will then need to create a resource group within it. And you will need to set a region where you want the resources to be provisioned. Next, we need an admin username and password. These start off as the local admins for each of the boxes, but they end up being the domain admin credentials for your SQL Kubernetes domain. Next, the GitHub branch we just leave as main. The IP address range will always start with 10, but the second point of the IP address will range from 0 to 255. This will allow you to deploy this multiple times into different IP address ranges. So for this one, I'm going to use 192. That means that my IP address range will be 10.192.0.0. Then we come to our SQL installation options, and the default is to install SQL 2019, 2022, and the monitoring. However, the DH2I license key is currently blank, and what that does is it means that it will install a standalone SQL 2019 and 22 instance. If you want to install the high availability, you must put a license key in here, like so. If you're going to do this manually, then you set these options to no. And when you do that, it will still configure the scripts for you to deploy via the next set of steps. What that also means is if you add your license key in here, it will provision scripts to deploy the high availability solution. If you leave it blank, it will provision the scripts just to deploy a standalone instance. So the final thing is how many nodes are going to be provisioned depending on the options that you select. Well, first of all, if we go with no for everything and a blank license key, then it will provision the minimum of one node, which will not have any pods installed on it. If we select 2019 as automatic, then it will provision this SQL pod on this one node. If we set the monitoring, that is absolutely fine. It will still provision one node. But if I also add 2022, that will now take us to a second node for the monitoring itself. If I add in my license key, instead of having one pod for each of these, we will now have 3 pods. So that will be 6 pods in total plus the monitoring. The 6 pods themselves, it will be 2 per node, and then we'll have an extra node for the monitoring. So that is 4 nodes. So depending on what solution we use, it will be 1 node to 4 nodes. If we set it to automatic and do everything, it will provision 4. If we set it to manual and do nothing, then it will provision 1 empty node. But then as we manually install our SQL services and the monitoring, it will then scale up all the way up to 4 nodes. So I'm now going to deploy this installing SQL 2019, 2022 with the license key, and I'm going to install the monitoring. Once the initial deployment is completed, we can have a look at the deployment details, and this tells us about all of the resources that have been deployed, including the virtual network, the machines, and the actual Kubernetes cluster. There was also a script that was deployed as part of this on the jump box itself, and that has already set up the domain and joined the jump box to the domain. So the next thing we need to do is to log into the jump box, and that will fire up another script, a logon script, which will then install and configure the Linux server. It will then set up the Active Directory ready to use for our containers. And then depending on whether we've set manual or automatic provisioning, it will either just set up the scripts, configure the scripts, or it will configure them and deploy the scripts, which will take roughly around 30 minutes. And that's what is going to happen here. So next, I'm going to go to the outputs. And one thing that we have here is the domain admin username, which is the username that we provisioned with the actual domain suffix as well. So if I copy this to the clipboard, I can then go back to the overview page and over to the resource group. I can find my Jumpbox resource and then connect via my Bastion host. So it asks for the username, which I've just copied, and then the password as well. And then when we connect, it will log us in, and then it will bring up a PowerShell script, which will then take, in this case, around about 30 minutes to deploy. So once the PowerShell script has completed, we can start to have a look at our environment, starting with the deployment folder on the C drive, which contains a logs folder, which captures everything that went on while deploying our lab environment. Also, there are the scripts that we use to create the environment, plus other files which we have generated and have either used already or are going to be using when we're doing a manual deployment of our SQL instances. Next, if we have a look in PowerShell itself, we can actually have a look at what has been deployed in terms of the Kubernetes nodes, the pods, and the services. So starting with the nodes themselves, if we run kubectl get nodes, we find that there are 4 virtual machines in our scale set that have been created. They're numbered 0 to 3. If we now have a look at our SQL19 deployment, so this is in a namespace called SQL19. So if I run kubectl get pods with the namespace of SQL19, it tells me that I've got 3 pods that are running, 1 for each of our SQL instances. And then we can delve deeper into this and actually run a command that shows some custom columns, including the nodes that the pods are running on. So if I run this again under the namespace of SQL19, you can see that node 0 and 1 are being used. Node 0 currently only has the 1 SQL19 pod, which is instance 0, while node 1 has instances 1 and 2 on there. And if I do something similar for SQL 22 and have a look at the 2022 instances, we can see that instance 0 is also on node 0 for this one, but instances 1 and 2 are on node 2. So that just leaves node 3, and that will be using our pods that are working for our monitoring solution. So to find this, if I do SQL monitor, which is our namespace for the monitoring solution, and you can see Grafana, InfluxDB, and Telegraph are all installed and configured here, and they are on node 3. Finally, we can take a look at services. So if we run kubectl get services, and this one is just for SQL19's namespace, you can see the IP addresses on 10.192.4 and then 0, 1, 2, and 3. 0 for instance 0, 1 for instance 1, 2 for instance 2, and 3 is for the availability group load balancer or the availability group listener. So finally, if we have a look at the instances themselves, so I'm going to connect, and initially, if I try connecting using just the NetBIOS name, it's going to fail with an SSPI issue. And that is because we've set the service principal names against NetBIOS and against the fully qualified domain name, but the certificates that are being used for channel encryption are only against the fully qualified domain name. So NetBIOS name will not work in this scenario. So if I change that now back to the fully qualified name and connect, you can see our instance is available, and we have a AdventureWorks 2019 database already configured, and it is in a synchronized state. And that is in an always on availability group. This instance is the primary. We've also got instances 1 and 2 as the secondary. There is our database, and we have this as our listener. So now if I connect to the listener, if I try using port 1433, it will fail. Again, in terms of the service principal name and the listener port itself, we're using 14033 for this. So if I change that to be 14033 and connect, and now you can see the listener is available. So I go to databases, and again, we're there. Look at the always on high availability, and you can see that we are on the primary, which is instance 0. Likewise, if we take a look at 22, in a similar way, we have an availability group running on here, but this one's a contained availability group. So you can see there are actually 3 databases that are listed here. As well as our AdventureWorks 2019 database, we also have a copy of master and MSDB, which are being replicated between our 3 nodes. Again, 22 AG1 is the availability group, and the listener is AGL1. There are 3 instances. Instance 0 is the primary, and we've got these 3 databases listed. However, if we now go to the listener itself, and again, if we connect using port 14033, there is no reference to the other 2 databases, the master database copy and the MSDB. Using contained availability groups, when you connect to the listener, there is no reference to high availability. So it looks as if it's just a standalone instance, but there is an underlying availability group underneath. So there is no folder for availability group, and you can just see this one database. The system databases include the usual master, MSDB, and tempDB. There is no model database here. The model DB is actually on the underlying instance. Also, the master database and the MSDB database are not the system databases on the node. These are actually referencing these 2 databases, which are replicated across all 3 instances. This allows you to be able to create logins, jobs, credentials that are shared between the 3 instances as part of this listener setup, and are not actually configured on the underlying nodes themselves. The final thing that I want to show is the monitoring solution. So I'm going to go into Edge, and in the first tab, I'm just going to type in influx db : and then the port number 8086. This takes me to the InfluxDB login page. The username is the same user that you added into the deployment, and the same with the password. Once you're in, if you go to sources, or in fact, if you go to buckets, you will see there is a SQLmon bucket, and also there is an aligned SQLmon telegraph agent as well, and that is what is taking the or collecting the data from the SQL server and then putting it into the InfluxDB database into the SQLmon bucket. So if I go into this bucket and then just paste in a query into here and then run it, and this is starting to show us some of the telemetry that we are getting from the telegraph agent that is storing into InfluxDB. So next I'm going to go and look at Grafana, which does the visualization based on the data that is in InfluxDB. So if I go to a new tab and go to Grafana :3000 as the port number, and again this is going to take me to a login page, same credentials again. And once we're logged into here, we can go to the top left corner, onto the menu and go to dashboards. Once we're in there, you will see there is a dashboard already set up, and once we click onto there, you will see the metrics are being collected and they are being visualized on the dashboard. Everything that you see here is all currently based on the 0 node for SQL 19. If you want to change to any of the other instances, just go to the host, expand the drop down, and you can select whichever host you want. While this monitoring solution is not using stateful sets, it's just using deployments, it is using persisted volumes, and that means if you delete or if one of the pods crashes for InfluxDB, Telegraph or Grafana, you may find a little blip, but it should then pick up again and everything work fine. And that is it in terms of a quick walk around the SQL Server Kubernetes project and deploying a full solution.